On this question, we want to solve the following logarithmic equation. The equation we're working with is log base 3 of x plus 30 minus 3 equals negative log base 3 of x plus 4. I wanted to share with you a couple of the typical methods that we use for solving logarithmic equations. So two of the methods that we see most often are to convert that logarithmic equation to an exponential, or to use the one-to-one property for logarithms. So let's take a look at both of these formats and see if it matches what we have. So in this method of converting to an exponential, we would have an equation with a log only on one side of the equation. And then we rewrite that log as an exponential. So looking at this example, I can see that I have a log on the left and a log on the right. So it doesn't really seem to match the first one. Then we look at the second one, and the second method is using the one-to-one property of logarithms. And in this example, or in this property, you would need to have log base b on one side and log base b on the other side in order to reduce that equation in this way. And so once again, we do have logs on each side, but we do have a problem in this 3 here. So with this 3, it doesn't allow me to use the property of the one-to-one property, or some books call this the property of equality. So that 3 is really throwing a wrench in things. So I'm going to look again at this converting method and see if maybe there's some manipulation I can do to make this happen. So what I want is logs only on one side. And if I move some terms around, I can maybe make that happen. So let's see. What if I add log base 3 of x plus 4 onto the other side and add 3 onto the other side? That means my equation would look like this. Log base 3 of x plus 30 plus log base 3 of x plus 4 equals 3. So this is looking a little bit more like what we have in this method of converting to an exponential. But we need to go a step further. With this method, we need to have a single log, and we have multiple logs. So we're going to use our properties of logarithms. There are 3 properties that are commonly used to condense logarithms, and those are the product rule, the quotient rule, and the power rule. So let's take a look at those. So here I have the properties that I just mentioned, the product rule, the quotient rule, and the power rule. So if we read these properties starting on the right-hand side, moving to the left-hand side, we call those condensing, because we're starting with multiple logarithms and condensing down to a single logarithm. So what we need to use a property like this is to have log with the same base on both logs, and you need to be adding or subtracting. If you're adding or subtracting, you're either going to use the product rule or the quotient rule. So we're adding, so we're going to use the product rule. So the reason it's called the product rule is because you take the expressions inside of the log and you multiply them together, creating that product. So that's what we're going to do with our example. We're going to condense these 2 logarithms. They do have the same base, and they condense to log base 3 of x plus 30 times x plus 4 equals 3. So we were able to condense to a single logarithm, and now that we've condensed, we are now able to use that property that we were talking about earlier, or that method that we were talking about earlier, to convert to an exponential. So we want to follow this pattern to convert to an exponential. Notice that the base of the log is the base of the exponential. So the base, for our example, the base will be 3. Then the log always equals the exponent. So this log equals 3, and that becomes the exponent on our exponential expression. And this is going to equal the expression inside of our logarithm. So it's going to equal x plus 30 times x plus 4. So this creates an equation that doesn't have a log in it, and we're going to use some of our other algebra techniques to solve. So let me move this property out of the way and we'll continue solving. We have 3 to the third power is 27. We're going to multiply the right-hand side. That becomes x squared plus 4x plus 34x equals 120. We're going to subtract 27 on both sides, and that gives 0 equals x squared. We can combine those together to get 38x. And 120 minus 27, okay, I need to do some borrowing here. So let's borrow from the 2. 10 minus 7 is 3. 11 minus 2 is 9. So we've got a plus 93. All right, so let me rewrite that a little nicer. X squared plus 38x plus 93. I'm going to see if I can factor this. See, factors of 93 will be 193, 3, and 31. Okay, so I've just had some help catching a mistake. So you'll notice that when I did this multiplication, I did x times x, which is x squared. I did x times 4, which is 4x. Then I started to get a little bit ahead of myself in my brain. 30 times x should be 30x. Instead, I wrote 34, so I was thinking ahead about combining like terms. So this should be a 30x. And then I've got 30 times 4, which is 120. And this is a plus 120, not an equals 120. Okay, so then when I add these two together, this should be a 34 instead of a 38. So let's correct that. 34 here. All right, so now this looks a little bit better with our factoring, because 31 plus 3 will give us the 34 that we want in the middle. So we've got x and x, 31 and 3, and we want both of them to be pluses. We're going to set each factor equal to 0 using the zero product property to get x equals negative 31 and x equals negative 3. Now this is a log equation. Log expressions have restricted domains. So every time we solve a log equation, we need to check to make sure that it works in the original equation. So we've got the original equation shown up there at the top, and I'm going to check x equals negative 31 in the original. We've got log base 3 of negative 31 plus 30 minus 3 equals negative log base 3 of negative 31 plus 4. And The restriction that log expressions have is that you can only take the log of positive values. So if I look inside this log, negative 31 plus 30 is a negative value, and log of a negative is undefined. The same thing happens over here in this log expression. Log of a negative is undefined. And so we have to throw that solution of negative 31 away. So let's check the other one. Let's check x equals negative 3. We have log base 3 of negative 3 plus 30 minus 3 equals negative log base 3 of negative 3 plus 4. Negative 3 plus 30 is a positive value. Negative 3 plus 3 is a positive value. So we can keep that solution of x equals negative 3. And that is our solution for this log equation. Thank you for checking out my videos. Have a great day.